Unfortunately, the records for which fields have tile drainage installed are not always available or even exist. So in this video, we're going to go over a tool which identifies fields that are likely to be tile drained based on soil and slope conditions. When we open up the TileDrainage Classification tool, we see that we have multiple inputs, including the field boundary feature class, the G-Surgo roster, which is what contains our soil information, and then the slope table. We also have a couple conditions, and then a logic gate, which will tell us whether we want the relationship between these two conditions to be more restrictive, using AND, or more inclusive, using OR. So let's take a closer look at these conditions that can be chosen for this tool. The first one deals with slope and states that at least 90% of the field is less than 5% slope. The second condition deals with soils. The user has to select one of these, and those are that the field has a mean hydric soil percentage of at least 10%, or they can choose that poorly drained soils, this is D-class soils, occupy at least 40% of the field. Based on the user's knowledge of the watershed and how the soil survey was conducted, they'll have to make a choice between these two. On the right, you can see the difference between the D-class classification and then the 10% hydric classification. Finally, the user has to make a choice of using an AND statement, which is more restrictive, or the OR statement, which is more inclusive. When using AND, both the slope and the soil condition has to be met for that field for it to be classified as tile drained. When using OR, either or of those conditions can be met or both can be met for it to be classified as tile drained. Alrighty, so we're back in our map document. You'll notice I switched watersheds, but no worries, we're still on the same track. So to begin, we go over to our field characterization toolset within the toolbox, go down to tile drainage classification, open that up. You can see we have multiple inputs. We're going to get one output, that's the drainage table. The first input is our field boundary feature class, so I'm going to grab that, drag and drop in. An important thing to note here is that this feature class has a join on it right now with the slope table, and that's not going to work. These tools don't run well when there's a join. They don't run at all. You're going to get an error message that says there's a join, fix this, basically. So I need to right click it, go to join and relates, remove joins, and remove all joins. So now we just have our plain base data in that field boundary feature class. The second input is the G-Surgo roster. It's been automatically populated. Third is our slope table. There it is. And then we have our conditions and logic gate. The first condition is never going to change. It's always going to be that at least 90% of the field has less than 5% slope. Then we have our logic gate. I'm going to choose AND in this case to be more restrictive. And then condition 2 of the soils, I'm going to go with hydric soil percentage must be at least 10%. You'll use your local knowledge and other resources to make these decisions. And then we have our output automatically populated, going to the right place, so we hit OK. Alright, so our tool is just finished running. You can see we have our drainage table automatically added to our table of contents. So let's open it up and take a look at some of the fields we've got. We have that field boundary ID field again, which will be useful for creating the join with the field boundary feature class. Our ISAG field, which tells us if a field is cropped, pasture, or non-agricultural. And then we have a percent hydric field, percent dual drainage field, percent slope less than 5%, and then a drained field. Based on G-Surgo, we calculate the area weighted mean of the hydric percentage of each map unit within a field to calculate this percent hydric field. For the percent dual drainage field, we calculate the percent of a field that consists of either dual drained class soils, that's AD, BD, or CD, or just D class soils. And then the percent slope less than 5 field is the percent of the field that is less than 5% slope. And based on the query that we used when we ran the tool, we get an output of whether the field is likely or unlikely to be tile drained, or if it's non-agricultural. Based on the query you used and the quality of your GSurgo data, you may be satisfied with the results of this tool. However, if you have local knowledge as to whether a field is drained or not, and it doesn't happen to match these results, or you would like to generate another query using this data, you can change these results here. You can start an editing session and change them manually, or if you open up Field Calculator, you can create a new query in here and get a new output for your drained field. This is just a little bit of info if you'd like to explore further into this information. However, it's not necessary. So let's visualize this tile drainage table. We'll do that by creating another join with the field boundary feature class. So we right click, joins and relates, join. This time we're going to select the drainage table. Still going to use that field boundary ID, boom, and hit OK. Then we'll go into the properties, symbology, go to categories, and we're going to choose that drained field. Add all the values, and take some time to symbolize it however you see fit. And yes, okay. Apply, okay. And now we get an idea of which fields are likely to be tile drained, shown in blue, and which ones are not as likely, shown in this pink-red color here. If we open this up, take a look, we can go to the non-likely to be tile drained and look at these other three fields, and in my case I used that percent hydric and then the slope condition. And I can see why these aren't likely to be tile drained. For example, here, my hydric seems to be just fine. It's all above 10%, at least for the majority. There are a few that don't qualify. But it seems more so that the percent slope being less than 5% is the reason that these are not tile drained. You can see that these are not making that 90% or higher of each field qualification. So this is helpful for visualization, but don't forget to actually look deeper into your table to see why they are or are not likely to be tile drained. Here's a brief recap of everything that we did to figure out which fields are likely to be tile drained based on soil and slope classifications.